Okay, guys, we're pretty much out of time on the Olds project, but I think I got it where I'm pretty happy with it for what it is. If we can take a look at our fin, we've got Dykem nice and parallel to it. It's pretty much right on the money. And let's take a look at the valve. The valve looks pretty much totally clean. Let's take a look at the bore. Okay, I think the bore looks good, right? Nice and wide, nice splatter. Good. Okay, right down its throat. Looks pretty good. I did round our roof fin a little bit and brought it down. I also raised the roof right at the short side apex because it was a little tight. It's still a little tight for 6,500 and 500 cubes, but I kind of like it where it is. We're going to see what the owner says about it before we do any more. Okay, this looks pretty darn good from this angle to me. You can see the in the middle of that Dykem, it goes from one epoxy to the other epoxy. The marine epoxy I don't like nearly as much. But as far as our Dykem flown next to that fin, I think that's pretty much unbeatable. That looks great. How'd we do on the other one? Not nearly as much on the right-hand side. You got a lot of dust and crap, but pretty good as far as parallel. Okay, you can see the fin. I knocked it down quite a bit and rounded it. We still have a couple inclusions here and there, but not too terrible. All right, sorry guys, we got to use this one again. I don't really know which way is up or down here. So let's just compare what we can compare down here. Now, when you raise the roof, I figured I would lose a little bit at the bottom because you're losing airspeed there. So we got a minus, an equal, a minus, minus. And then we got plus, plus. And I'm pretty sure we got pluses all the way down. We also top out better. We were 321 here, and we're 328 here. So that's a decent step up in CFM towards the higher lift range. And remember, there's going to be a lot of demand on this because it's going to be a big engine. So I'm pretty sure that's going to work really well. Nice and quiet. There is the slightest transition right around 500 where it's going from around the short side to windowing, but you hardly lose anything. It's much better, much happier. It actually works better than the outer port, but the outer port flows more. So I can see where this one's going to make a little more power, and it really kind of makes sense to me. As far as our swirl curve, this is what we had. And we started going off the short side at 400. Here we're going off the short side at 500. Okay, so it's a little better as far as losing it and windowing at a little bit higher lift, right? We have more area. That makes perfect sense to me. This is pretty much dead. You just fill, 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 and then you go off the other direction. And we have, if we're running a 750 cam, we got more swirl than we need. But as you can tell by the Dykem, it wants that fin in that direction. In order to reduce that, we would have to kind of make a swirl port out of it and put the fin. We would have to move it probably 20 or 30 degrees. And I'm not interested in doing that. I'd rather get as much flow as I can out of these for what they are. And let my airspeeds carry me. Okay, let's do our airspeeds. Okay, we were 228. We're now at 243. 228, 231, 213, 210. So we're moving more air at 0.8. I should write on here 0.8. And you can see we got more action on the roof. Okay. Now this may be a little skewed because as the bowl changes shape, I may have stuck the pitot down a little bit further because I was trying to get our max air speeds. I didn't do that on this one. But we can see they're not quite even. But then I used a flow ball, a pretty big flow ball, like a 1/2 inch flow ball, right down that groove. And you do that, you see which one loses more CFM. Even though it's slower, you got more air going through that side. So you have to think about it. Before you go too crazy with your air speeds, you got to see which way the air wants to go. A lot of it wanted to go on the center of the cylinder. And when you put a flow ball right around here, you lost more CFM than if you put a flow ball right around here. Now you can see this has got more area, right, than this does. So that kind of really makes sense. And as far as our short side, we went from 356 to 382, 388 to 391, 376 to 360. We dropped a little speed on our cylinder wall side, but our cylinder wall side has trouble because it's got that bolt boss there. So it's actually a good thing that we took a little of the speed off of that corner. And I think that's going to really kind of work out well. What we should probably do is compare this one to our mostly done outer. Let's see if I can find that. Okay, this is the last one I could find, right? Number 6. I don't think I did one after that. That was, I can see I CC'd the port, right? And I changed the angle of the chamber, how it exits. And this is what we've got. We've got a decent curve, right? We're 230 at 300, which is good. We're topping out right around 344, 345. I was surprised. Now, I put these pluses and minuses in reference to these flows. I wasn't really expecting this. This flow's better, equal, better, and 2 minuses. In reality, I think they're probably going to make almost the same power at this point. I'm going to wait for some input from the owner before I do anything else on these. I've got a couple good jobs rolling in, so this is going to go on the back burner. But give me your input on port-to-port comparisons. Right, this one has practically no swirl, but it tops out a touch better. This one actually has a better curve all the way through. And it goes off the short side and gets the swirl. This one doesn't get the swirl until it's all the way up in the lift range. So that is a 0.9 inch lift, which it's not going to get that big a cam. But of course, we're also doing this at 28 inches. If you put a 500 inch motor sucking on it, it's going to change up and down a little bit. All right, guys, thanks for hanging out. Have a good night.